So it should be the second journal entry that I gave you. That's not one that you have to handwrite. All right. So first, we're just going to review what we already know. All right. So first off, the definition of an inverse. An inverse is defined by reversing the inputs, so it's the x value, and the outputs, that's the y value of a function. So just some things to note about that. Biggest thing, switch x and y. And just know that inverses undo each other. So if a function is an inverse of another function, they will literally undo each other, which we saw yesterday when we started doing all those evaluations. All right, so you guys remember like when we had those two functions and we plugged in different x and y values in and they ended up undoing each other? That's what I mean by undo each other. All right, I'm just going to slide up a little bit, but if I go too far, just let me know. Now, let's review the first type of method we saw with seeing inverses, which is through a table. Now, a table is probably the easiest way to deal with inverses because each ordered pair is reversed. So in other words, if I have xy, that's what I start with, the inverse would be yx. So that's what I start with. And the inverse is what I end with. Now, for example, we're going to do just like we did in the warm-up. So if my function, all right, and remember that can also be written as f of x. X and y. Let's say I had 2, 4, 6, 3, 7, -5. All right, what would be my inverse table? And remember, you can write that as f -1 of x. So what would be my inverse table? So x and the inverse of y. Yeah. So what would be the inverse table? So what's my x values for the inverse? 3, 7, negative 5. So my y's become my x's. So that means my new y's are 2, 4, 6. So literally they just flip-flop. So my y's from the original become my x's for the new, and my x's from the original become the y's. So that's with the table. And again, this is stuff that we already know. All right. This is just kind of the review stuff that you need in your journal just for note wise. Now, with a graph, let's just say I make a quick coordinate plane. I only really need 2 dashes each. So, if I plotted these points here, let's say I made a quadratic graph. Let's call this one f of x. So my original points for that are -1, 2, 0, 1, and 1, 2. So those are my original functions. All right. What would my inverse points be? So what points would I graph for my inverse? 2, -1, then 1, 0, then 2, 1. So I got 2, -1, and 2, 1, and then 1, 0. And so this graph would be my inverse of f of x. Now, we talked about this yesterday, but I said that this inverse is technically a reflection. So from function to inverse function, the graphs are reflections of each other. Does anyone remember what line I said it reflects over? Y equals x. Good. So don't forget, inverses are reflections over the line y equals x. Because remember, the rule for y equals x is literally this. You start with xy, you change it to yx. So we'll make a note that f of x and f -1 of x are reflections across the line y equals x. And so just to recap, you start with xy, it becomes yx. Another thing to note is that even though they're reflections, they can still intersect. Often on the line y equals x. So for example, if you had the point 4, 4, what's the inverse of 4, 4? 4, 4. All right, if you got the same number as both x and y, obviously the inverse will just be itself. Any questions so far on the things that we talked about yesterday? So that's the tables and the graphs and what an inverse actually is. So again, this is all review from yesterday. Also, if you can't read a word because my handwriting is lovely, just to say the least, just let me know. You're not going to offend me. I got a math teacher's handwriting, not an English teacher handwriting, and y'all know what I mean by that. My numbers are prettier than my letters. All right, is everyone good? Because I'm about to scroll up. All right, so here's the new thing. How to rewrite an equation for an inverse. All right, so we're going to start with the actual steps. So the first step is to rewrite the equation switching the x and the y. Yes, ma'am. Yes. Once we rewrite it, and again, if you don't understand these steps just yet, it's okay. We'll do an example, so just write them down for right now. Then, yeah. Then solve for y. And then lastly, we rewrite using the proper notation. So that is either y to the negative 1 power, which signifies inverse, or using f of negative 1 of x. Either one of those signifies that that's our inverse function of y or the inverse function of f of x. All right, now let's do an example. So we're going to start with the function y equals 2x minus 4. So this is a pretty basic inverse equation example. So first step is literally switch x and y. By that, I literally just mean switch the placement of the x and y variables. So if I do that, this would be x equals 2y minus 4. So when I say switch x and y in the equation, I literally mean switch where x and y are placed in the equation. And by the way, little pro tip here. This is a little Desmos hack that will help you on the EOC. If you are asked to find the inverse function, all you do is take the original, switch x and y, graph that in Desmos, and it actually will graph the inverse graph for you, which you can generate a table from to get points. And that can help you get the function. All right. So if you actually put this exactly into Desmos, it will actually graph the inverse function for you. Just a little pro tip. All right. Now, second step is we're going to solve for y. So we're going to pretend that y is our only variable. We're trying to get the y by itself. So treat this just like we're solving a two-step equation. Even though we have x on this side, that's okay. We're just trying to get y by itself. So almost pretend like x is like a number. All right. So what would I do first to get the y by itself? You would add 4 first. Good. So first thing I would do, I would add 4 to both sides. So that cancels out. Now, this is the same thing as combining like terms. So can x and 4 combine? No. No. So we literally rewrite it as x plus 4 is equal to 2y. Still trying to get that y by itself. So I'm trying to get the y by itself. So what's my next step to get the y by itself? Divide by 2. So I'm going to divide both sides by 2. That goes away, and now y should be by itself. So x plus 4 over 2 is equal to y. And you can literally leave that like that. So 3, our last step is to rewrite it using the correct notation. So we would write this as y to the negative 1 power is equal to x plus 4 over 2. Another thing to note is if you broke apart this fraction, all right, meaning you put x over 2 and then 4 over 2 individually, because you can do that. X divided by 2 is just 1/2, so 1/2 x. And what's 4 divided by 2? 4 divided by 2, guys. 2. So another way you could write it is 1/2 x plus 2. Either one of these is correct, but honestly, if you just get down to there, I'm happy. Now, that was a very, very simple one. So let's do some that are a little bit harder. So wherever you have room on that page, we're going to do 3 more problems that I'm just going to actually give you, and we're going to work them out together. All right. So that was a really easy one. Let's try one that's not as easy. All right. So still on that journal entry. So it's just wherever you have space. All right. So let's do a second example. So we'll call this one example 2. And let's do f of x is equal to 2x squared plus 5. Now, do not get thrown if they write f of x instead of y, because what is f of x? Y. So if it helps, first thing you should do before you even do that is just rewrite it instead of using y instead of f of x, just so it doesn't throw you. So what is my very first step? What do I got to do? Switch the x and the y. So this will be x is equal to 2y squared plus 5. And now I'm going to solve for y. So again, we're treating y as the only variable. So what is my first step? Right, we got to subtract 5 from both sides. So someone besides Anna, what would be my new expression? Besides Anna. Good. All right. What's my next step? Someone besides Anna and Marley. So I'm still trying to get the y by itself. Right. Divide by 2. So my new expression will be x minus 5 over 2 is equal to y squared. Now, the y is still not quite by itself. What's the last thing I need to do? Someone besides Anna, Marley, or Jonathan? Square root it. So, x minus 5 over 2, all square root is equal to y. So my last step is to just rewrite it using the proper inverse notation. So you could say y to the negative 1, but because it was originally an f of x, I'm going to use f of negative 1 of x is equal to the square root of x minus 5 all over 2. So guys, if you can get it down to just that, I'm happy. All right. And remember, all this is, it's for finding inverses. So the key here is inverse operations. You're undoing the operation, just like how you would solving an equation. So like, for example, if we were adding the 5 originally, that means you have to subtract it to get rid of it. All right. Because that will undo the add 5. All right, let's do another one. So let's call this example 3. So let's do f of x is equal to 2 times x minus 5 squared plus 1. So first things first, just for confusion's sake, I'm just going to rewrite f of x using y. So if you see f of x instead of y when you're doing an inverse, just replace f of x with y, just to save you the heartache. So first step, someone who has not talked yet today. Nope. So we cannot distribute that 2 because of that square right there. All right. But we can get rid of the 2, just not yet. I got to do something else first. What's always the first thing you do with an inverse? Switch x and y. But then you would subtract the 1. That's the next step. So first things first, you got to switch that x and y. That's why I said there's one thing you remember about inverses. Switch x and y. Switch x and y. Switch x and y. Because remember, that's how we solve for y. We can't solve for y if y is already y equals. All right? But then we would do what Hunter said and subtract 1 from both sides. So the goal is we're trying to get these parentheses by itself first so that we can take a square root to get the y by itself. So we got to undo everything that's on the outside of the brackets. All right? Just like when we were doing function transformations, when I said, you start inward and work your way outward. Well, when you're finding inverse functions, you start outward and work your way inward. All right? So this would be x minus 1 is equal to 2, y minus 5 all squared. Still solving for y. What am I doing next? Someone who's not talked yet today. Guys, heads up, please. So, I want to get these parentheses by themselves. So I got to take care of the what first. Is there anything outside of the parentheses? We can't square root yet because there's something else. The 2. What operation is happening to the 2, the parentheses? What's it doing? Multiplying. So how do I get rid of it? Divide it. So this would be x minus 1 all over 2 is equal to y minus 5 squared. What's my next move? So what's my next move here? Now we can square root both sides. So don't add the 5 yet until you get rid of the square. So if we square root both sides, the square goes away. I have the square root of x minus 1 all over 2 is equal to y minus 5. So what's my last step to get the y by itself? Add the 5. Now, the 5 will be added outside of the radical. We can't just throw something in a radical willy-nilly. All right, so when you rewrite it, it should be the square root of x minus 1 over 2 plus 5 on the outside of the radical is equal to y. So if I rewrite it using f of x, I have f negative 1 of x is equal to the square root of x minus 1 squared plus 5. So that one was a little bit more complicated. All right. So the key with equations, especially if you have stuff in brackets, you start on the outside and you work your way in. Another way I like to say it is SADMEP. Anyone know where I got SADMEP from? SADMEP. It's PEMDAS backwards. All right. So if you don't know where to start, think SADMEP when it comes to solving equations. You're doing PEMDAS backwards. All right. All right, last one, and then I'll let you guys work on your delta math for the rest of class. So, example 4. I have f of x is equal to 3 times the 4th root of 2x minus 5. So first things first, I'm just going to rewrite it using y. So y is equal to 3 4th root of 2x minus 5. So, what's my first step? Switch the x and the y. This becomes x is equal to 3 4th root of 2y minus 5. And we're solving for y now. So think SADMEP. In SADMEP, what operation comes first? Subtraction. So what do you think I'm going to have to get rid of first? The 5. All right, and how do I undo it? You add it. So add 5 to both sides. That goes away. I have x plus 5 is equal to 3 4th root of 2x. So we took care of the SA of SADMEP. What's next? Division or multiplication. Do I have division or multiplication anywhere? It would be what number? 3. So even though I have one next to, I don't know why I wrote x there. That's supposed to be y. But even though I have it next to the x, we are treating this bracket like parentheses. All right? Which we know parentheses is like one of the last things we do. So if you have a bracket of any kind, and we already know what dignifies a bracket from transformations. All right? If you have a bracket of any kind, treat it like parentheses. All right? So how do I get rid of that times 3? We divide by 3. So x plus 5 over 3 is equal to the 4th root of 2y. Now, think about the next step carefully. So in SADMEP, what comes after multiplication division? Exponents. Now, technically, a root is an exponent. All right? So how do I undo a 4th root? Think about it this way. How do you undo a square root? Squared. How do you undo a cube root? Cube it. How do you undo a 4th root? Raised to the 4th power. Good. So I want to raise both sides to the 4th power. That goes away. I am not going to do any simplifying there. I'm just going to leave it as parentheses x plus 5 over 3 all to the 4th power is equal to 2y. I'm not going to do anything fancy there. What's my last step to get y by itself? So now we're at the parentheses. So that was what was under the bracket. So that's what we have left. So what do I have to do? Divide both sides by 2. And we're going to divide that entire parenthesis by 2. So my final answer, and honestly, you can leave it just like this, would be x plus, oops, 2 too small. X plus 5 over 2, all to the 4th power. That's not 2, that's 3. All divided by 2 is equal to y. So if I rewrite it using f of x, we get f negative 1 of x is equal to all of that mess divided by 2. Now, are there ways you could simplify that function? Sure. Do I expect you to do it? Heck no. All right. If you can show me that you know how to undo all those operations to get down to here, I'm happy. All right, Miss Murphy's a happy camper. Could I simplify that? Heck yes. Do I want to? No. All right. I could. Like me personally, I could. Do I expect you to do it? Absolutely not. All right. Again, this is more about can you do the process, not can you do something overly complicated when you don't need to do overly complicated. All right. Any questions on inverse stuff? All right. So for the rest of class, what we're going to be doing is, since I haven't given you any work time, like at least an extensive amount of work time lately, the rest of class, and you've got a solid 45 minutes. I want you guys working on your delta math. So you have the new 1.4 delta math. And I'm also, one other thing. So the first thing that I want everybody to do